Okay, so this is a video for the last page of section 5.2. So in this problem, we have an acute right triangle with tangent is 0.5. So remember, tangent is opposite over adjacent. So that means that the opposite side over the adjacent side is equal to 1/2, which is the same as 0.5. So I can draw this triangle, and then I have my angle, and I know that the opposite is 1 and the adjacent is 2. And I'm going to find all the values of the remaining trig functions. So this problem, I don't know whatever the hypotenuse is. But as always, I can find it using the Pythagorean theorem, which states 1 squared plus 2 squared equals h squared. So simplifying this, I get 1 plus 4 equals h squared, and 1 plus 4 is 5. So h equals the square root of 5 in my example. All right, now I can get all of the other trig functions. So I know that sine is opposite over hypotenuse, so 1 over root 5. And then by the reciprocal identity, the cosecant is root 5 over 1. Cosine is adjacent over hypotenuse, and its reciprocal is secant. So secant equals root 5 over 2. And then lastly, we know that the cotangent is the reciprocal of tangent. So that's how we can do this problem. So you've seen quite a few problems that are similar to this. Obviously, this is something that is important to know. Okay, look at number 10. We are asked to find the secant squared of 28 degrees minus the tangent squared of 28 degrees. We aren't able to put this in a triangle because we don't know any of the side lengths. We need to at least know some of the side lengths. So then we suspect maybe that we should use an identity because that's the only other thing that we have. So if you can remember the Pythagorean identity that states tangent squared theta plus 1 equals secant squared theta, we can apply this identity here. So basically, I have secant squared of 28 degrees. I can replace that with tangent squared of 28 degrees minus 1 for this part here. And then I still have to plus 1, sorry. And then I still have to subtract tangent squared of 28 degrees. And so the tangent squared minus tangent squared is 0, and we're left with just 1. Okay, so this one simplified down all the way to 1. So lastly, number 11, given the sine of 30 degrees is 1/2, find the cosine of pi over 3 and the tangent of pi over 6. So right away we need to be careful because we're given at least 2 angles and we're using both degree measure and radian measure. So probably the first thing I'm going to do is change this 30 degrees into radians. So we know from before that 30 degrees is pi over 6. So the sine of pi over 6 is 1/2. So this at least lets me set up a triangle. So I have pi over 6, and I know that sine is opposite over hypotenuse. This would allow me to find the tangent of pi over 6, but I'm still very wondering about the cosine of pi over 3. But I think the thing to realize is that the sum of the 3 angles in a triangle is always pi. So because I already have a pi over 2 and a pi over 6, that means that the remaining angle is actually pi over 3, because I know that pi over 6 plus 90 plus whatever that other angle is has to equal 180. So that's how I solved and found that the other angle is pi over 3. So this is a very special question, engineered to work out, okay? So now I think I can answer the problem if I can at least just find the remaining side length using the Pythagorean theorem. So I know that a squared plus 1 squared equals 2 squared. So a squared plus 1 equals 4. Subtracting, I would have that a squared equals 3. And by the square root, a equals the square root of 3. So now I have my triangle. So the cosine of pi over 3 is the adjacent over the hypotenuse, but you have to be careful because that is talking about relative to pi over 3. Relative to pi over 3, this is the adjacent side. So this one is adjacent to pi over 3. So as I said, it's always relative. So the cosine is adjacent over hypotenuse 1/2. So that's part of the problem. The other part was to find the tangent of pi over 6. So we know that tangent is opposite over adjacent, but be careful because now we're talking about pi over 6. So this is pi over 6. So 1 is opposite of pi over 6. Okay, so it depends what angle you're talking about. So the tangent of pi over 6 is 1 over root 3. Okay, so that's it for section 5.2.